In this video, I want to talk about APM alerts. In a previous video, I demonstrated how to set up APM integration so that you can monitor the performance of your instrumented services. So in that video, we set up a Node.js API REST service and a Golang REST API service. We then instrumented it so that we can monitor its performance. But one area I avoided discussing in that previous video was the alerts tab. The alert system is a way to be notified of interesting events that occur in your infrastructure. In our case, we want to be notified if our instrumented services exceed particular metrics around errors, failures, or latency. And I want to discuss alerts in this video. While recording this video, I realized that the alert functionality is large enough that it could be broken up into two videos. So I didn't realize that until recording this. So in this video, I want to show how to set up alert rules, trigger those rules, and have the alert notification appear in Kibana, very much like what you're seeing on the screen right here. And also in this video, I want to demonstrate specifically three different rule types, which are the error rule threshold, the failed transaction rate threshold, and the latency threshold. So I'll discuss all that in this video. And then in the near future, I'm going to publish a second video. That second video is going to discuss how to get these same notifications in other services or devices. So these alert notifications, we want to be able to get them in an email system or into a separate logging system, or maybe publish them to your Teams channel or Slack channel. I want to discuss how to consume and relay these notifications in a separate video, which I'll publish in a few days or maybe a week or so. So hopefully you find the rest of this video useful on how to just set up the Kibana alerts and have them appear in here, and for me to demonstrate each of those notifications. This video is going to continue off of two earlier videos that I made. The first video shows how to set up ElasticSearch server and the Kibana server. In my video, I kept them as two separate servers, but if you choose to keep them on the same server, just use the appropriate domain names and IP addresses in your YAML configuration files. But the process is pretty much the same. In the second video, I showed how to set up APM integration. And in that video, I actually went through quite a bit. One of the things I went through was how to set up a fleet server, which is what your Elastic agent must run on. Again, in that video, I set up the fleet server as a third server separate from Kibana and Elastic. But you could have just as easily kept the fleet server on the same server as Kibana or Elastic. Again, just use the appropriate domain names or IP addresses in your YAML configurations. Also in that APM video, I demonstrated how to set up agent policies. We set up two REST API projects, a Golang one and a Node.js one. We instrumented it, and then we had the APM actually monitor the data and submit it to Elastic Stack. So if I click to this menu icon, I go to observability and I click on APM, you'll see that these have been set up from our previous video, the Node.js app and the Golang app. And I have both the Node.js and Golang app running in the background through a systemctl service on my server or my own local computer. So I have this is the Node.js app. I have it set up on my local computer somewhere. And this is the Golang app that I have set up on the same computer, just running on a different port. So these are running just 24/7 in the background through a systemctl service. And if I show so this is the Golang script that we actually created in our last video. And this is the Node.js app that we created in our last video. So we're going to continue off from here. Now, one of the things, I guess what we're going to talk about next is setting up the alerts. If you go into one of these services and you click on alerts, you'll notice that there are just no alerts, right? Alerts are just going to be any kind of notification around interesting things about the performance of your software that you want to be aware of. You'll notice that it doesn't actually do anything at this point. And to actually set anything up, you actually have to go to observability, alerts, And under here, you click on Manage Rules because you have to define some rules to specify what events you actually want to monitor, you want to be monitoring or notified of. So if you click on Manage Rules, you get the option to create your first rule. If I click Create Rule, you'll see that you're not allowed to because there's some additional setup that's required in your Kibana server. So that's where we're going to continue this video from. All right, so to enable the ability to set up rules, we actually need to SSH into our Kibana server and make some changes there. So here's my terminal window. I've SSH into Kibana server. You go into the etc folder, go into the Kibana folder, and you can see that there's a kibana.yaml, which we set up in our last video. What we need to do is actually add a property here. And one of the things you could do is just add this property anywhere in the file. It's the xpack.encrypted_saved_objects.encryption key. And this needs to have a value of at least 32 characters in order for you to be able to enable the alert system in Kibana. So if I paste something like this, that would definitely work. So actually, if I paste this and I just save a restart Kibana, the create rules section in this website or in this web platform will start working. But this is not the most secure way to do things because I don't like leaving plain text secrets in configuration files like this. So I'm not going to do that. I'm just going to undo. And I won't actually make any edits to this kibana.yaml file at all. Instead, I'm going to go to the USR share directory, go into the Kibana directory, go into the binary directory, and we should have the ability to use the Kibana key store. So I'm just going to run that, add the property name. So it was the xpack dot encrypted saved objects dot encryption key. Press enter. Now we can just type in any string that's at least 32 characters. So pick something that's a little bit hard for people or any machine to guess. And now we should be able to restart Kibana. Oops. Right, so it might take a few seconds, a few minutes, just see if there's any errors that occur. All right, so I'll give it a moment. Okay. Yep, there are no errors. Oh, and I noticed that the website automatically refreshed because when you restart Kibana, things will just automatically restart. I will log back in. And now if I click on create rule, we now have all these different options for creating rules. Right? So now you're ready to set up any alerts, not just for APM, but for any of the other alerting systems and any of the other observability features. Let's explore some of the rule types that we can create. So when I click on create rule, you'll see that we can set up, we'll have to give a human readable name for the rule that we're about to create because we can create so many. It's just easier to read the name of rule written in plain English so you can right away identify what it's for. You can specify how frequently you want to check the rule, and you can specify when you want to be notified, whether there's a status change or every time the alert is active or on some custom action interval. I'll explain more of these probably towards the middle of the video, or it could be self-evident as I'm demonstrating some of the rules. Now, the next part, which I really want to bring your attention to, is the rule types. Now, you can see over here, there are 4 rule types grouped together for APM. There are 4 rule types under APM. And these 4 rule types are anomaly, error count threshold, failed transaction rate threshold, and latency threshold. So these are the 4 that I'll demonstrate in this video. if you scroll down some more, you'll see quite a few other rules actually. There's 2 rules for infrastructure, which is related to this section here on the left, infrastructure. Now these rule types are not directly related to APM. So you have to just think of them as separate things. Log rules, also a separate rule type, and uptime rule types, also separate from APM. As you do more integrations into Elastic Stack and have more capabilities and more functionality, more rule types could appear here. But for the purposes of this video, we're going to focus only on the 4 rule types specific to APM. All right, so with that said, let's talk about setting up an anomaly rule type. Now, this one's actually not available to us out of the box with Elastic Stack. You actually need a gold subscription, or if you try to create it at the time, sorry, let me just say this again. At the time of creating this video, if I were to try to create an anomaly rule type, it will say that a gold plan or gold subscription is required. So if you go to the subscriptions website or the subscription area of the Elastic Stack website, you'll see that the gold plan has been discontinued. And I've been told that if you use platinum, then you will have the ability to use the anomaly rule type in the APM area. As well as if you have the platinum platform, the platinum subscription, you can actually open up a lot of other features available in the Elastic Stack. Right? So when you're ready to move on to more advanced capabilities of the Elastic Stack, do consider one of these other subscription plans with the Elastic. All right, so that's the anomaly rule. So I won't go into that one. What we'll talk about next is the error count threshold, which alerts when the number of errors in a service exceeds a defined threshold. So this is a very useful alert rule type. So we'll set that up. Let me scroll up to over here. Let's give our error rule type a name. So I'll just say error rule type, or I'll just say, error rule threshold. How often do you want to check? Normally they don't recommend checking every 1 minute. It could be quite resource intensive for your server, but for the purposes of this demonstration, might as well just check every minute because we don't really have too many other things running. I want to be notified every time the alert is active. Okay, so, and which I'll show some of the other different notification types afterwards. All right, so let's click on error count threshold. And what we want to do is, now if you recall, we have 2 different apps that we made, a Golang app and Node app. We could do both, or we could just do just one. I'll monitor both of them for all environments. And if we get, let's say, more than 2 errors in the past minute, then we should be notified of an alert. What you're seeing here in this image is just historically up until 10 o'clock, which is around the time of this recording, there hasn't been any error types because I haven't actually triggered any errors recently. But if I did, it'll just show you historically this red line could be above or below some of the thresholds, just as a way for you to preview whether this alert would have been fired. So I'm going to go ahead and, so let's say more than 2 errors in the past minute. Now the actions. Actions is related to how you can actually be notified of when the alert happens. By default, any alert that happens will be visible within Kibana. What the actions do is, if you want other ways to preview to be notified of an alert, either it could be stored in an index within Elastic, it could be written to a server log, it could be emailed to you, it could be posted to Jira, could be posted to Teams channel or a Slack channel, just many different ways of being notified. These first 2 come with a free version of the Elastic Stack. These other ones you can see requires the gold license, which I mentioned. If you have the platinum license, it would be sufficient for you to enable some of these features. In a future video, I will demonstrate how to use the index connector and the server log. I'll also show how to ping the Kibana API to grab the alerts. And these other ones that require the Platinum license, feel free to explore on your own when you're ready for some of the more advanced features in the Elastic Stack. I just want to first demonstrate that this rule actually works. Right? So by setting up to this point without a connector, you will be able to see rules fired within Kibana. So let's save this. And it will take a moment to load. All right, so it's pending. If you hit refresh, eventually this will say okay. And if we click back to the alerts area, you can see that none of the alerts have fired. I click on manage rules. You can see this rule is actually active, or sorry, not active. It's in the okay state. Now let's actually trigger something. I believe this actually sends an error. So let me take a look at my scripts again. Some of those. So for Node.js, if we hit the /error endpoint, so this is my Node.js one. I'm just going to refresh this a few times. So that's definitely more than 2 errors per minute. And we click to services. Maybe it could take a while for it to, actually, let me just click here. Yeah, it takes a while for it to register. Okay, there we go. We see some response there. I believe these are errors. Yeah, so you can see we have 9 errors in just that one moment. Click on alerts here, and there we go. So you can see now that this error is in an active state. If we click on the other way to view it as well is under just the general global alerts area. Error count is 9 in the last minute for Node app 1, alert when there's greater than 2. Now, if we wait a minute or so, and we don't actually try to cause any more errors on the website, that is, let's not ping this URL anymore, this alert status will change to recovered because this was only in the past minute that we hit 9 errors per minute. So let's hit refresh. Okay, I'm going to pause the video for a moment and return to it, let's say, in 5 minutes or so. And you should see that this alert rule will disappear from here, or it will only show up in the recover. Oh, all right. I didn't have to even pause it. So you can see that this alert rule has changed state to recovered. And which goes to saying, I want to return to this rule type. And if we want to edit this rule, this is where this drop-down notify, you want to be only notified when it's active, but you could say whenever there's a status change between active and okay, or okay and recovered, or any other possible states that could appear in Kibana alert rules. Okay, so that's how the error count alerts work. All right, well, let me just discard some of these changes. Right, so let me just think if there's anything else. No, I think that's pretty much it. Just that's all there is to the error alerts rule. You can create multiple of them. You can have it focused on just one app, one service, one instrumented service, whether just the Golang one or just the Node.js one, by click on edit rule. I don't want to monitor all services. I could monitor just one of these services. So you can play around with any of these settings and they should be fine. Okay, so yeah, pretty straightforward. Error alerts is pretty straightforward. Let's explore the next rule, which is the failed transaction rate threshold. Alert when the rate of transaction errors in a service exceeds a defined threshold. So according to APM Kibana, a failed transaction is any HTTP response in the 500 series. So that could be as an example, a 500 internal server error would be a failed transaction. So it would be a 504 gateway timeout. Now, any HTTP response in the 400 series is not considered a failed transaction. So as an example, a 404 not found is not a failed transaction. This is because a service typically implements, a service typically will intentionally implement 400 rules. So a service or software developer will create a 404 response as a way to intentionally notify a client device that the resource you're trying to request doesn't exist. Or even setting up a 403 forbidden, a service will use a 403 forbidden response to intentionally notify a client that the resource you're trying to request, you do not have sufficient privileges to access that resource, right? Those are just some examples, but 400 HTTP responses are generally within the domain of a service, whereas 500 responses are generally outside of a service's domain. A developer would design their service in a way to minimize the amount of occurrences of 500 series errors. So that's why 500 series are going to be considered failed transactions, whereas 400s are not. So let's just demonstrate this. I'll give my rule a name. I'm going to scan every 5 minutes. I've noticed that if I run this rule at 1 minute, sometimes Kibana, the Elastic Stack, isn't, or at least within my setup, it's not fast enough to process the information that APM gives it, and therefore the rule doesn't trigger. In fact, in a realistic production environment, I might just run this rule once every 5 minutes or 10 minutes. 1 minute could be too resource intensive. A bit too resource intensive for the Elastic Stack to trigger the rule. I'm going to click Failed Transaction Rate Threshold. Now, if I were to implement this rule, all services for all requests, for all types, for all environment above 30% for the last 5 minutes, you can see a preview of what of that rule here on whether it would have been triggered or not. The reason you see some data here is because prior to recording this video, I was just testing, kicking the tires a bit just to see if things would work. And you can see that this red line here is focused on the 30%, and at around 11 o'clock, that rule would have fired. Okay, so let's just update this rule. What services? You know what? We'll just use all the services, and for all the types, for all environments, is above 30%. No, I'm going to change this to 2% just to ensure it gets triggered, and then we'll set up an experiment that will trigger this rule. We want this to scan for, we're only looking at transaction rates for the past 5 minutes. Again, if I set this for the last time period, if that time period is 1 minute as an example, that would be too small of a window. And at least for my Elastic Stack setup, 1 minute is not enough time for Elastic Stack to consistently process this rule. So setting it for 5 minutes, in fact, let's just play it safe for the last 10 minutes, right? So if we experience failed transaction rates for the last 10 minutes and we're scanning at 5 minute intervals, then we'll trigger this rule. Okay, so let's do that. All right, so I'm going to press save. All right, so the rule is pending. If I hit refresh in a moment, oh, there we go. So the rule is in effect, and it's going to be monitoring. So let's actually set up the experiment. I'm going to go to my local computer. I'm going to go to my Node.js app, and I'm going to create a new endpoint. So I just have some code. Let me just copy and paste it. So so what this is saying, if I hit the endpoint /fail, and I'm going to give a 500 response, and that's the end of that. Just a simple change like that. All right. And now I'm going to, so I had this service, this API, Node.js API running through a systemctl. So I'm going to stop it and I'm going to refresh it. in fact, so let's just so you can see what the service looks like. Right? Really, all it is just running the node service or binary on the index.js. So let's just start this. All right, so the API has been updated. Let's just double check that if I were to go to that endpoint, good, it's up and running. All right, so now that the service is up and running, and let's double check that it does appear in our Node app. Do we have, we have a failed transaction right at 11:34, which is the time of this recording. Let's now consistently ping that endpoint so that we can hit a rate greater than 2%, which I think is what we set our rule to be. So let's go to, I have a script already made in advance. Let me just see, test. So I have this ping.sh script, which is just ping this URL, wait 1 second, and then keep doing it because this is an infinite loop. All right. So I will go ahead and just run this. And I'm going to let this thing run for 10 minutes. So I'll be back in a moment to check on this. It's almost been about 10 minutes, not exactly 10 minutes. But let's just check. If I go to observability, I go to APM or alerts. In fact, let's just look at APM first. You can see that the transaction rate, failed transaction rate for the Node.js app has been pretty high. And if we go to the alerts, you see there's one active. Failed transaction rate is 100% in the last 10 minutes for Node app 1, alert when greater than 2%. So our rule seems to be working. If I click on manage rules, you can also see it in this view here where the state is currently at active as opposed to OK. If I click in here, you can see that this rule is running just fine. So what I'll do next is I'm going to come back to our bash script. I'll just stop it and I'll wait a few minutes and then I'll come back to the website just to see that this rule has recovered or gone back to an OK state. Okay, I've waited for maybe about 15, 20 minutes. Let's take a look at the alerts. And yep, you can see that the failed transaction rate rule has recovered. If we click into, let's say, manage rules. And yeah, so everything looks okay. And let's just take a look at APM services for a moment. Right, you can see that there's no more failed transactions because we stopped the service a while ago. But if we increase the window, I just want to double check a few things. Right, the last time we had the failed transaction was 11:42, which is about 20 minutes ago from the last time we recorded. Let's look at the last rule type, which is I believe it's the latency threshold rule type. Alert when the latency of a specific transaction type in a service exceeds a defined threshold. So basically, if we can cause one of our API endpoints to take longer than usual to execute, and that should trigger this latency threshold rule. So let's go ahead and set this up. I'll just call it latency threshold. I believe for this rule type, I was able to make it work at 1 minute if we check every minute. But in production, you probably want to set a check interval of something greater than a minute. I'll just leave this as only status changed. Let's pick latency threshold. And one thing that I noticed that I have to do is I can leave all these other variables the way they are, but I must set this to request. If I don't set this to request, then this rule type never seems to fire. If someone else understands why, please explain in the comments to this video. I think that'll help everyone out. Instead of average, actually, sure, I'll just leave it as average. And let's say we'll reduce this to 100 milliseconds just to make sure it does trigger. And then we'll set up an API endpoint that takes a little bit longer than usual to fire off. I will leave this for 5 minutes as well, but if you have any trouble, try making this a slightly greater window, and that might increase the likelihood of this rule type being fired, because maybe Kibana, your Elastic Stack, takes a little bit more time to process the data that APM gives it. And again, I'll demonstrate the connector types afterwards. So let's set up this rule. Oh, okay, so you actually do have to set a service name. So I guess latency threshold can only work on one service at a time. And yes, that makes sense. I remember some of my earlier experiments required this. All right, so let's do that. We're going to do it for just a node service. We'll add actions later. We'll let this thing create. I'll hit refresh. All right, so this rule is ready to be used. So let's update our REST API. We'll go to node this, and I'm going to add one more endpoint. Let me copy my code from a different screen that I prepared in advance. Okay, so we're going to create a new API endpoint called latency. And what it will do is just wait 10 seconds. We're going to wait 10 seconds before sending a response. And yeah, so that 10 seconds is definitely more than 100 milliseconds. So that should trigger our latency rule. I'm going to restart my node service. All right, now let's just check if it's working. All right, so it's going to take a while. 1, 2, 3, 4, 5, 6, 7, 8. Oh, all right, okay. So yeah, that took about 10 seconds. So I think our API is ready to be used. And what I will do then is, let's go to our bash script again, so we can simulate this or test. I have this ping.sh, and maybe what we'll do is, I'll comment this out. And we'll ping the latency endpoint instead. Ping it once, sleep a second, and just infinite loop, repeat this again over and over again. So, okay, and when this happens, while that's going, let's double check our services. I just want to click into here, and I believe there should be some, oh, the first graph here is latency. So most of the time there's very little latency, but I think now that we've started this ping, hopefully we will see the latency here increase. I'll give it a moment. And there you go. You can see here on the right that we're starting to see latencies of 10 seconds. I wonder if that already triggers the rule. Yeah, all right. We already see that the rule has already been triggered, that we have some API endpoints that are taking more than 100 milliseconds to fire. So if we click to manage rules, you can see that the latency rule is already active. So this concludes how to set up APM alert rules in Kibana so that they appear in these visual dashboards in Kibana. In a future video, I will discuss how to get these same notifications in your other client devices by using, let me just click one of these, by using a connector type, whether it's index, a server log, or pinging the Kibana REST API to grab all the details you need to notify your other devices. So if you stay subscribed, you should be able to get notifications on when that next video gets published.